All right, let's jump right in. Today, we're talking about something called category theory. Now, I know that sounds a little intense, but trust me, it's actually this incredibly beautiful and powerful way of looking at the world. It's like a secret language that lets you see the hidden connections in, well, just about everything.
I mean, think about that for a second. It's not just some dry mathematical field. People who use it literally describe it as a superpower. It's like putting on a new pair of glasses and suddenly seeing the deep patterns that connect all these different fields you thought had nothing to do with each other. It's about seeing the forest, not just the trees.
So here's a puzzle to kick things off. What on earth could possibly connect the way an AI learns to see a cat in a photo with the fundamental rules of geometry? I mean, they seem like they're from completely different universes, right? Well, by the end of this, you'll see how category theory bridges that gap.
So yeah, a superpower for patterns. The real magic here, the thing that makes category theory so special, isn't that it creates new stuff. It's that it reveals the hidden symmetries, the shared structures that are already there, everywhere. It's all about using abstraction to find universal truths.
And this right here, this is the absolute heart of it. Category theory asks us to make a really important shift in our thinking. Stop obsessing over what things are on their own. Instead, pay attention to how they connect, how they relate, how they interact. Because in this language, the relationships are the whole story.
Okay, so if this is a universal language, how does it actually work? Well, like any language, it's got its own grammar. So let's break down the essential building blocks. And don't worry, we're going to keep this super simple and intuitive. First up, the most fundamental concept of all, a category. And really, all a category is a collection of two basic things. You've got objects, which are just whatever you're interested in, and then you have morphisms, which are basically just arrows or relationships that connect those objects. That's it.
The easiest way to get your head around this is to think about basic grammar. The objects are like the nouns in a sentence, the people, places, things. And the morphisms? Those are the verbs, the actions, the transformations, the things that link the nouns together. It's just a system of nouns and the verbs connecting them.
So if categories are these little structured worlds, how do we connect them to each other? Well, that's where a functor comes in. A functor is this really special kind of map. Its job is to translate one entire category into another one, while making sure it perfectly preserves the original structure of all those relationships.
A functor is basically a perfect translator, right? Imagine translating a poem. A really good translation doesn't just swap out words one for one. It keeps the rhythm, the meaning, the emotional structure. A functor does exactly that. The things, the objects themselves might look totally different, but the pattern of arrows between them, it stays identical. The structure is perfectly preserved.
Okay, stay with me, because this is our last and most abstract piece of grammar, the natural transformation. So if a functor is one way to translate a structure, what if you have two different translations? A natural transformation is like a bridge between those two different functors. It's a map between maps. It's how you check if two different ways of looking at something are actually consistent.
So let's break that down. Here's how it works. You start with two different functors, so two different translations of the same original pattern. A natural transformation then comes in and builds a bridge connecting the results of those two translations. It's basically a quality check to make sure that these two different points of view are related in a coherent, consistent, or natural way. It's a relationship between relationships.
Phew! Okay, so now that we have the basic grammar, categories, functors, and natural transformations, let's get to the fun part, the payoff. Let's see how this language actually allows us to connect completely different, seemingly unrelated worlds of thought. And believe me, this isn't just some abstract exercise. Category theory is being used as a unifying language for an absolutely incredible range of fields. I mean, look at this list. We're talking computer science, the very foundations of logic, systems theory, and even super advanced geometry.
So, let's start with computer science. Remember that puzzle I threw at you at the beginning about neural networks? Well, some people are now looking at the learning process, the famous backpropagation algorithm, and realizing it's a functor. It's a structure-preserving map. This view reveals this elegant, hidden mathematical structure inside machine learning.
And its impact on logic and the foundations of math is honestly even more profound. You have these whole new fields popping up that use these ideas to connect the super strict rules of logic with the much more fluid, intuitive world of geometry.
This is actually changing how mathematicians think about something as basic as what it means for two things to be equal. It's wild.
Then there's systems theory, basically the study of how things regulate themselves. Category theory provides the language to model everything from this quirky thought experiment called cybernetic kittens all the way to the incredibly complex circuits in our own brains. The amazing part is, the underlying patterns of control and inference are the same.
And in geometry, these ideas are absolutely essential. There are tools built on this theory that give mathematicians a solid, rigorous way to stitch together tiny, local pieces of information into a single, coherent global picture. You can think of it like taking 1,000 satellite photos of individual streets and seamlessly combining them to create a perfect, flawless map of the entire planet.
So after seeing all these incredible connections, let's just pull back and bring it all home. What's the ultimate takeaway here? What does all this give us? Well, it really is about gaining a completely new way to see the world.
In the end, the real power of thinking this way isn't about the individual nouns, the objects. It's about finally seeing and understanding the rich, complex, and beautiful web of relationships that connects everything. Because it turns out, the structure is the story.
And that leaves us with one final, pretty tantalizing question, doesn't it? If this language can show us these deep, shocking connections between fields we always thought were separate, it just makes you wonder what other profound, universal patterns are still out there, hiding in plain sight, just waiting for us to find the right way to look.